In this section, we're going to start taking a look at the idea of probability. And probability in its rarest, in its most, I guess, general form, is the idea that we're trying to figure out chance, the likelihood that some random event is going to occur. Now, let's get some basic definitions down before we go forth. So, one of the most basic things that we have to do with probability is we have to conduct an experiment. And an experiment is some sort of test that involves a number of variables and then also some sort of results of the variables. Each time that we see something happening, that's an observation or an outcome. And an observation or an outcome is just the result of one of these trials or one of these experiments that as a result of basically one iteration of the experiment. There's a certain set of all possible outcomes, and that's going to be a sample space. So for instance, if you flip a coin, there's only two things that could happen. We could either get heads or tails. So the sample space from flipping a coin would be heads or tails. If you roll a single die, the sample space would be 1, 2, 3, 4, 5, or 6, the outcomes of the size of the die. And so eventually what we're trying to do is we're just trying to figure out how often a random event will occur, or the likelihood. And that's the very definition of probability. So probability is going to be the study of determining how often a random event will occur, provided that we have a sufficiently large number of trials, all right? And that could mean like thousands, tens of thousands, or hundreds of thousands. Now, for those of you that have gone through pre-calculus or college algebra or something like that with functions, you might recall seeing this, P of A, as a function. In this course, think of P of A as not a function any longer. Just know that to mean the probability that event A will occur. And probability of A occurring is essentially a relative frequency. It's the number of desired outcomes divided by the total number. Right? So you might remember in your frequency distribution, we had a column for relative frequency. That's exactly what we're computing, a probability, the likelihood in that experiment or in that data collection or that cross-section, whatever it might be, that observation, that outcome will truly happen. All right. Now, the range of probabilities is 0% to 100%. A lot of times, though, we like to put it in terms of not a percentage, but a real number. So another way to say that is from 0 to 1, all right, well, inclusively of the 0 and the 1. So just some really basic examples of probability. So let's define a sample space S to be ABC 1, 2, 3, 4, 5. Let X be a randomly selected element. Let's compute the following. So we want to find out if I was to theoretically reach into this bag. All right, so let's just put all the elements inside of a bag. So we have A, B, C, 1, 2, 3, 4, 5. And let's say for some reason I was just reaching in this bag. So that's my hand. All right. And I'm just reaching in the bag and I'm trying to pull out one of those objects. Okay. Then what we're trying to do is we're trying to figure out the likelihood that I'm going to pull out a 2. And the first thing we need to do is figure out how many total elements are in the bag. All right. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry about that. Pen got locked up. But you can count that we have 1, 2, 3, 4, 5, 6, 7, 8 observations. So total is going to be equal to 8 for this problem. And so how many 2s are in the bag? Well, there's exactly 1, 2. So for letter A, the probability that X is going to be equal to, and X is a random element, number of desired is 1, total number is 8. Right? And we could write that as a percentage by sticking it into the calculator. So in our calculator, we just type 1 over 8, and that would be 0.125. And then finally, if we wanted to convert that into a percentage, that would be 12.5%. So this is mostly what a lot of people understand. Most statisticians want 1 out of 8. For letter B, probability that X is less than or equal to 4. So we just go in here and we find that there are 1, 2, 3, 4 out of 8 of the total values or the total items in that bag that are less than or equal to 4. All right, and we know that that's going to be 0.5 or 50%. Now, this one's a little bit sneaky. We say, what's the probability that x is between 1 and 5? Because the inequality is not underlined, we are going to exclude 1, but we're going to include 5. All right, so when we go ahead and take a look at all the observations that satisfy this, we know that we're going to have 2, 3, 4, and 5. So that's the probability that 1 is less than x, less than or equal to 5. There are 4 observations out of 8 total that are going to fit that criteria. And then what's the probability that x is going to be a letter? Well, that's pretty easy. We just go in here. We see that there are 1, 2, 3 observations or 3 items that are letters. So that's 3 out of 8. In our calculator, we can stick that in. We get 0.375 or 37.5%. And then finally, what's the probability that x is going to be equal to d? Well, we go in our list here, and we see that there are no letters that are d in this list. All right, so I'm going to get rid of all the underlines because I don't really have anything in here that's a d. All right, so I got rid of part of my bag there, unfortunately, so draw that. And so for letter E, the probability that x is going to be equal to the letter D is 0 out of 8, which is 0, which is 0%. All right, so hopefully that's pretty easy for you all to do. Another type of probability example is going to be a contingency table. Now, a contingency table basically relates 2 different variables. So we have gender, male, female, and then the frequency of how often they smoke. And we're just trying to figure out some probabilities based on that. So for letter A, we're asking what is the probability that somebody in the study smokes and is male? So smokes often, excuse me, is male. And the first thing we need to do is we need to figure out what the sample size is. So what we're going to do is we're going to add those up. So we're going to have 37 plus 15 plus 94 plus 42, 13, and 82. 42 and 13 and 82. And that gives us 283. All right, so n is going to be 283 for this problem. So the probability that somebody smokes often and is male. So male and smokes often is 37. So for letter A, that's 37 out of 283. And if we shove that in the calculator, 37 out of 283 is going to be 0.131 if we were to approximate the 3 decimal places, or 13.1%. For letter B, what's the probability that somebody is female and does not smoke? All right, so that would be, we look at our female column, or female row, excuse me, and they do not smoke, and there's 82. So that's going to be 82 out of 283. Right? We throw that in our calculator. That's going to be 0.2897, so 290. Again, if we were to approximate the 3 decimal places. Right, so that would be 290. Or 29.0%. Now, sometimes it doesn't have 2 conditions in the question. So for instance, what's the probability that somebody in the study smokes casually? And that's all it says. It doesn't say male or female. So what we're going to do is we're just going to add those up. So we have 13 plus 15, which is 28 people that fit the criteria. So that would be 28 out of 283. And 28 out of 283 is going to give us roughly 0.099. All right, so, or 9.9%. And then finally, for letter D, what's the probability that somebody in the study is a female? All right, so we're just going to go through. We're going to add up our females. All right, so we have 42 and 13, which is 55. 55 and 82 is 137. I'm just going to check that using the calculator real quick. So 42 plus 13 plus 82 is indeed 137. And we're going to take 137 and we're going to divide it by 283. All right, so we're going to get 0.484. All right, so we do this. First of all, we're going to take 42 plus 13 plus 82, and that's 137. And then to figure out the probability, we're going to take 137 out of 283, and that was approximately 0.44, or 48.4%. All right, so that's our basic introduction to probability. All right, not meant to be too difficult. When you give me your answers, if you just want to leave it in the fraction form, that's fine. One thing to note, you shouldn't ever go through and reduce the fractions, right? And the reason you don't want to do that is because this fraction, 37 out of 283, tells us how many successes divided by the total number in the study that we were looking at. All right, so if you reduce it, like for instance up here we had 4 out of 8, if you reduce that to 1/2, then somebody that's a probability sort of person might think, okay, well, there was 1 success out of 2 opportunities instead of 4 successes out of 8 possible opportunities. All right, so again, don't reduce the fraction, but do stick it into the calculator and do get this decimal and that percentage. That'll be pretty helpful to anybody else that's looking at this.